Today we're going to solve equations with complex/imaginary solutions. Complex and imaginary mean the same thing. All right, let's take a look at number 1. X squared plus 9 equals 0. Well, it's a binomial, and I can't factor it and t-bar it because it's not dots, so I'm going to have to solve it the old-fashioned way. So I'm going to subtract 9 on both sides and end up with x squared equals a negative 9. To get rid of squaring, I'm going to square root both sides. I'm going to end up with x equals, I drew the square root symbol, so I have to remember to give plus or minus, and the square root of a negative 9, as we all know now, is 3i. Now let me explain to you why you have to give the positive and a negative. It's very important to remember when you draw the square root symbol that you give the positive and the negative answer because you're not sure which one they want. And let me show you why they actually mean the same thing. If I took the positive answer, 3i, and I square it, it's basically 3i times 3i, which comes out to be 9i squared, and we know I squared is a negative 1, so I get my negative 9. So it works. Now let's try the negative guy. If I have a negative 3i, the whole thing squared, I have a negative 3i times a negative 3i, which will give me a positive 9i squared, which again is a negative 9. So both of them give me the same answer. So that's why I need to make sure I always give both answers. All right, let's take a look at number 2. Consider the polynomial x to the 4th minus 3x squared minus 4. What are the solutions to this polynomial? All right, well now, let's think about this. Hopefully you were told in your algebra days that the highest exponent tells me how many solutions I'm supposed to have. Well, let's take a look at my highest exponent. It's a 4. So I should end up with 4 solutions. Okay, let's see what happens here. It's a trinomial, so I'm going to try to go to 2 binomials and t-bar. Let's see, to get x to the 4th, it would be an x squared and an x squared. Factors of a negative 4 that'll give me a negative 3 will give me a minus 4 and a plus 1. Well, I don't want a t-bar yet because it looks like x squared minus 4 can be factored even more. Isn't that dots? So I'm going to have x plus 4 times x plus 2 times x minus 2 times x squared plus 1 equals 0. I'm going to t-bar from here, but I'm going to start to get a little nervous. And the reason I'm going to get a little nervous is because it looks like I'm only going to have 4 solutions. That I'm only going to have 3 solutions instead of 4. And I need 4. Well, let's see what happens here. Here I'm going to end up with a negative 2. Here I'm going to end up with a positive 2. The last term I'm really not sure what I have, so I'm going to do it step by step. I have x squared plus 1 equals 0. I'm going to subtract 1 on both sides and get x squared equals a negative 1. I'm going to square root both sides. I drew the square root symbol. So I'm going to end up with x equals plus or minus I. So that gave me my other 2 answers. So now I have 4 answers. So my answers are negative 2, positive 2, and plus or minus I. All right, how many x-intercepts does the graph of the equation have? And what are the coordinates of those x-intercepts? So to find out where that equation crosses the x-axis, I actually have to put it into my calculator. So I need you to pause the video, plug it into your calculator, and take a look and see how many x-intercepts you have and what they are. And then come back and we'll compare. Okay, so you have it in your calculator, and hopefully you are seeing only 2 x-intercepts. And the x-intercepts that you are seeing are negative 2, 0, and positive 2, 0. Now, when I'm thinking about x-intercepts are really my solutions to the equation. And I know I need 4 solutions because I just found them above algebraically. And graphically, I'm only getting 2. And it says, are the solutions of the polynomial equation the same as the x-intercepts of the graph of that polynomial? And we just realized that no, they're not. And the reason they're not is because we only have 2 real solutions. And only the real solutions will show up graphically. the other solutions all the solutions will always show up algebraically. So it's always important to make sure that you have all your solutions. If you can't find them all graphically, that means you're going to have to do it algebraically. All right, with that being said, let's go on to the next page, the next problem. Let's take a look at number 3. It says, write a polynomial p with lowest possible degree that has given solutions of the following, and explain how you generated your answer. Well, I have to take a look at this. It looks like they're giving me 3 solutions. Or are they? Remember what we did when we actually square rooted a negative number? We got an I value. And when we square rooted a negative number, we had to give the positive and the negative. So basically, we have to know that even though they're only showing us the positive answer, we really truly have -2, +3, and plus or minus 4i. They're not going to tell you that. They're hoping that you can visualize that on your own. And by knowing what we've done before, we now know that we have to give both. So what we're going to do right now to get the actual equation is we're going to do what's called backwards t-bar. We're going to actually go backwards up the t-bar to get our equation. All right, so my answers are x is a -2, x is a +3, x is 4i, and x is a -4i. So now I've got to back up the t-bar. All right, so here it is. And I'm going backwards because these are my solutions. So now I'm going to need 4 polynomials or binomials that will give me those answers. So this one's going to be x plus 2 because if I solved it, I'd get a -2. This is going to have to be x minus 3. This is going to have to be x minus 4i. And this is going to have to be x plus 4i. Okay, so now I have 4 binomials to multiply together. So I'm going to multiply the first 2, and then I'm going to multiply the second 2 to make things easier for myself. I'm going to end up with x squared minus 3x plus 2x minus 6. And then for the next pair, I'm going to end up with x squared plus 4ix minus 4ix plus 16i squared. I'm going to neaten up the first set and get x squared minus x minus 6. And the second set, I'm going to get x squared. The 4ix's cancel out. And I have, whoops, this should have been a negative, not a positive. Caught my mistake because a negative times a positive is a negative. -16 times I squared is a -1. So now I've got my positive 16. Now I've got a trinomial multiplied by a binomial, so I'm just going to take my time and multiply it out. I end up with x to the 4th plus 16x squared minus x cubed minus 16x minus 6x squared minus 96. I'm going to combine like terms and end up with x to the 4th, and I'm going to put it in standard form in the same time, minus x cubed plus 10x squared minus 16x minus 96. So there is my polynomial that if I solved it algebraically would give me all those answers. And again, I have to remember every time they give me an I as an answer, I have to remember that one of them was a positive and one has to be a negative. If I wouldn't have known that, I would have never have gotten this equation. Okay, let's go on to the very last question. Write a polynomial p with lowest possible degree that has the given solutions. In this case, they give me 0, 4, 2 plus I, and 2 minus I. So this time they gave me the plus I and the minus I. So I'm going to write down my answers, which would be x is 0, x is a positive 4, x equals 2 plus I, and x equals 2 minus I. I'm going to back up the t-bar. I'm going to actually write my actual binomials or even monomials. Let's see, so this is just plain old x. If I solved it, because I set the x equal to 0, that one was kind of easy. This one's going to be x minus 4. This one's going to be x minus 2 plus I. That might be a little confusing, but we'll see what happens. And this one's going to be x plus. Oh, no, this one's not going to be an x plus. This one's also going to be an x. Whoop, let me erase that. It's going to be an x minus parentheses 2 minus I. So they're basically both minuses because both 2's are positive. Okay, so let's see what I can do here. I'm going to neaten up those double parentheses in there to make life a lot easier for myself. So I have x times x minus 4 times, carry through that negative, minus 2 minus I. And this is going to be an x minus 2 plus an I. Okay, that's a lot easier for me to look at. All right, I'm going to multiply the x through by the x minus 4, and then I'll multiply these two guys together to see what I get. I've got x squared minus 4x. That was too easy. Let's do this one nice and slowly. I'm going to end up with x squared minus 2x plus ix minus 2x plus 4 minus 2I. I'm running out of room. Minus ix. I'll just continue it down here. Plus 2I minus I squared. Okay, that should be everybody. Let's see if I can neaten this up. So I have x squared minus 4x. All right, can I combine like terms and neaten this up? Let's see. I'm nobody to put with the x squared. I've got a minus 2x and a minus 2x will give me a minus 4x. The plus ix and the minus ix cancel each other out. I've got a plus 2I and a minus 2I. That'll cancel each other out. 4, and then I have a minus I squared. But I squared is a negative 1, so that becomes a minus negative 1, which is a plus 1. So I end up with a plus 5. Let me say that again. So this is a plus 4. This would be a minus negative 1, which is a plus 1. 4 and 1 make 5. Okay, so now this is a lot easier. It's a binomial times a trinomial. So I'm going to end up with x to the 4th minus 4x cubed plus 5x squared minus 4x cubed plus 16x squared minus 20x. All right, let's combine some like terms. X to the 4th minus 8x cubed plus 21x squared minus 20x. There's nobody else I can put together, so there's my polynomial. And the highest exponent is a 4, which means I did have 4 answers that they gave me that worked out through the t-bar, so I did everything correctly. If there's anything that you don't understand, please make sure that you either highlight it or write it down on a piece of paper and bring your questions to class tomorrow.